All right, this is video 1 for chapter 6 on linear equations and their graphs. And this video is focusing on a constant rate of change, otherwise known as slope. When we're talking about rate of change, we're going to take a look at the first example from our textbook on page 308. And it's an activity to explore rate of change from a ski lift. For this example, we have a graph provided for us of skiers as they ascend a ski lift to the top of a mountain. We see their horizontal position in feet as they travel from left to right across the mountain to their vertical position in feet as they travel from bottom up to the top of the mountain. A rate of change will always be comparing two quantities being measured. So this one, we're comparing their horizontal position to their vertical position. Now, if we look at this graph, we've been given 4 points. We have point A, B, C, and D. The first part of the example problem asks us to find the vertical change from point A to B, B to C, and then C to D. To find the vertical change, we're looking at the y-axis. So, from point A, we come up and see it's at 40 feet on the y-axis. If we went up to point B, we could follow it across to see it's halfway between 40 and 60, or at 50 feet. The vertical change is 50 minus 40, or 10 feet. For point B to C, we can repeat the same process. We see already that point B is at 50 feet. If we go up to point C and follow it across the y-axis, we'll see it marked at a distance of 90 feet. Then, to find our vertical change, we can repeat the same process. 90 feet minus 50 feet gives us what? You're right if you said 40 feet. Lastly, we're looking from point C to D. C, as we've said, starts at 90 feet. If we go up to D and follow it across on our y-axis for our vertical change, we see that D is at 100 feet. For our last one, from C to D, we can see a vertical change of 100 to 90 feet, or 10 feet. So when we are looking at the change, we could also say we're looking at the difference in values, which would say subtraction. The next part of the problem asks us to find the horizontal change from these points. When we see horizontal change, we should think x-axis. So if we repeated this process using the x-axis, we could find the change from points A to B, B to C, and C to D. Let's start with point A. Point A, if we travel down to the x-axis, is at 20 feet. Traveling across to point B, we see it's at halfway between 40 and 60, or 50 feet. What's the difference between 50 to 20 feet? That's right, 30 feet. Let's repeat that for part B to C. B, as we've said, is at 50 feet. If we go up to point C and follow it down to the x-axis, we see it's at 80 feet. What's the difference from 80 to 50 feet? You got it if you said 30. Lastly, let's look at C to D. We have C at 80 feet to D, which comes down to 110 feet. The difference from 80 to 110, you're right, it's 30 feet again. The very last part of this problem asks us to find the ratio of the vertical to the horizontal change. This is just following what we've already measured on our graph. We said the vertical change from point A to B was 10. Since it's a ratio, we will turn this into a fraction. It would be 10 over our horizontal change, which was 30. We can simplify that fraction to say that the ratio of the vertical to horizontal change is 1/3. We can repeat this process again for point B to C. On point B, we see a vertical change of 40 over a horizontal change of 30. If we simplify that fraction, what do we get? Good, 4/3. Lastly, we have point C to D. Again, we see a vertical change of 10 feet and a horizontal change of 30 feet. We simplify this fraction again to 1/3. So as we look at our rate of change, we look at the ratio of the vertical change over the horizontal change. These numbers that we got as our answers tell us a little bit about the slope of the lines. If you look at the graph from points A to B, it's telling us that it's changing at a rate of 1/3. From B to C, we see a rate of change of 4/3. And from C to D, we see a 1/3 change again. Just using our picture, if we looked for the steepest section on this graph, or I'd like to say the area that would be the most fun to see down because you would be going the fastest, I would say B to C here would be the area where you would have the highest rate of change. We can see that just from looking at the number 4/3 in comparison to 1/3. 4/3 was a bigger number, and on our graph we had a higher slope. So if you take a look at your notes, from this example, the first step that we took was finding the vertical change. The second step we took was finding the horizontal change. Remember, the vertical change was our y-axis, and the horizontal change was on our x-axis. The ratio of change then was our vertical over our horizontal change. It might be easier to say that our ratio of change was our y over our x. Now, if we look at this question, it says the steepest section of the graph has a higher or lower rate of change. Remember when we looked back, we said the steepest section had a higher rate of change. That's an important concept to remember. So I would underline or maybe circle the word higher. Now when we're talking about rate of change, there's a couple different terms that you might hear being referred to. As we've said already, you could think of the vertical over the horizontal change. You might also say your y-axis or your y values over your x-axis or your x values. Another way to think about rate of change is to say your dependent over your independent variable. Those are some terms that you're going to want to keep in mind as we go throughout this unit. Our next problem is a real-life example of rate of change. Since we're talking about linear equations, we're focusing on problems that have a constant rate of change. That means for constant intervals of change, you should see the same values changing on the other side of your chart. So here we see a real-life example of distance traveled over a period of time. So as our car is traveling 1 hour, 2 hours, 3 hours, 4 hours, we see the miles that they've gone on maybe the interstate. Over here we see that our hours are changing by 1 at a time. We go from 1 to 2 hours, 2 to 3, or 3 to 4. If we look over on the other side, we could use some subtraction to find the rate of change of our y values. We might see from 70 to 140 is a change of 70 miles. We could also see from 140 to 210 a change of 70 miles, or from 210 to 280, again, that's right, a change of 70 miles. You would know this is a linear function because the change from each one is consistent or constant. Now our problem asks us to find the rate of change between the 4th hour and the 2nd hour. If we went back to use our same process as before, we'd see that this is the change in vertical over horizontal, or in y over x values. Well, if we look at hour 4, our y values are representing the miles our car has traveled. So for the 4th hour, we see that it's traveled a distance of 280 miles. Now we wanted to find the difference, so we need to use subtraction to see how far it's traveled since the 2nd mile, which was 140 miles. Now we look at the change in our horizontal values, or our x values. That would be hours. So we say we're trying to find the difference from the 4th hour to the 2nd hour. If we subtract these, we get 140 over 2, which simplifies to 70 over 1. This means that as our car is traveling, it's going 70 miles for every 1 hour. Or you could say that it's like a speedometer going 70 miles per hour. That would be a rate of change. Another example is depth and time. Think back to when we did our videos in class as they filled water bottles, and we saw how it changed over time, how it filled the water bottle. This is an example of just a straight glass. That means there are no divots or curves or anything. It should be filling at a constant value the whole way across. So as we go from time on our x-axis, we're seeing how much depth we have added on our y-axis. We can find our rate of change here a couple different ways. I recommend finding spots where you see intersections from the x and the y-axis. Right here, we see at the point 2, 3, that there's a spot directly intersecting the axes. We could also follow this up to point 6, 9 to find another point. Or, does anyone see another one? That's right, right here at 4, 6. We can use these points again to find the rate of change on our graph. We're looking for, remember, the change in vertical values over horizontal. Let's pick 2 points. What points would you like to use that we've identified? Okay, how about 4, 6 and 2, 3? We can use these points to find our vertical and our horizontal change. If we go to 2, 3, we could draw our line across to see that on the y-axis it meets at 3, or we could just use the value provided for us in the ordered pair of 3. So we know that we're going from 3 up to, that's right, at our next point, cross the y-axis at 6, which you can also see in your ordered pair. That's a difference of 6 minus 3, or 3. Now remember, that's our vertical change. We still need to find our horizontal change. That's our change on our y-axis. We could, again, draw the line from our graph, if that helps us, see that this crosses the x-axis at 2. You can look at your ordered pair as well, if that gives you a hint. What about 4, 6? Where does that cross the x-axis? You could draw your line again, or look in your ordered pair and see that it crosses at the point 4. So we would say 4 minus 2 for our vertical change, which equals 2. This gives us a rate of change of 3 halves, or 3 over 2. That means for every 3 milliliters the glass gets filled, takes 2 seconds of time. You find those values from your axis here, where it says our y-axis is measuring depth in milliliters and our x-axis is measuring time in seconds. So, just to wrap it up in our notes, we've agreed that the ratio of change is a change of our y values over our x values. It might help us to think of the word change or difference, which would help us remember that we need to use subtraction when we're doing rate of change. We found the difference of the 2 points 2, 3 and 4, 6 using our graph on the previous page. Remember, when we did that, we took the difference of our y values over the difference in our x values to find our rate of change as 3/2. That's the end of your very first video.